reviewing Chapter 5, the forms of condensation and precipitation. So, what is a cloud? Well, a cloud is a visible aggregate of small water droplets and/or ice crystals formed when water vapor condenses within the atmosphere. So, for clouds to form, we need to have air rising, and this is known as adiabatic cooling. So, when air rises, it will cool and it will reach its dew point temperature and the air will be saturated. So, adiabatic cooling causes clouds to form as water vapor condenses in the atmosphere. And condenses, we learned the phase changes of water. This is condensation. So we know condensation is a warming process. So the air becomes saturated and there must be a surface for the water vapor to condense on. So this is known as condensation nuclei, and condensation nuclei act as surfaces on which the water vapor can condense on. And there are hygroscopic water-seeking nuclei, such as sea salt, which are more effective for condensation. And growth is rapid at first, but then slows as water vapor is consumed. Other sources of condensation nuclei would be dust from dust storms, particulates from volcanic eruptions, and pollen from plants. And with cloud formations, in 1803, English naturalist Luke Howard published a cloud classification scheme that serves as the basis of our present-day system. Howard's system classifies clouds on the basis of two criteria, which is form and height. So when we're looking at the form of clouds, it's broken down into three categories: cirrus, which are high clouds, and these are white and thin and wispy. And then we have cumulus clouds, which are globular, usually exhibiting a flat base, and they look like little cotton balls. And then we have stratus clouds, which are best described as layers covering much of the sky. And clouds are broken down even further by the height. So high clouds are above 6,000 meters, middle clouds range between 2,000 and 6,000 meters, and low clouds are at altitudes of less than 2,000 meters. And then we have another category of clouds of vertical development extended upwards to the span more than one height range. So this could reach the tropopause boundary layer. Again, the four major cloud groups and their types. So the first cloud group, it's in the realm of the cirrus clouds. So we have cirrus, cirrostratus, and cirrocumulus. So again, we're looking at the end names here because they repeat themselves depending on the layer. So cumulus, we'll see that these are like cotton balls, and then stratus, we'll see this type of layer. Again, with the middle clouds, we have altocumulus and altostratus, and three for the low clouds, we have stratus, stratocumulus, and nimbostratus. And then for the clouds of vertical development, we can see the first stage would be cumulus, and then cumulus-humulus, which are the puffy clouds, and then cumulus-humulus will grow bigger, and this is known as cumulus congestus. And then when the cumulus congestus gets even larger, it becomes a cumulonimbus cloud. So I have the order a little mixed up here, but I do have a slide on that order. So again, on the cloud classification, we could see here in this diagram the high clouds over over to 20,000 feet or over 6,000 meters. So we have the cirrus. So cirrus, cirrostratus, and cirrocumulus found on the highest altitude. And then for the middle clouds, we have altostratus and altocumulus. And then for the low clouds, we have the stratus and the stratocumulus. And then we have the category of vertical development. So again, here it tells us the cloud forms. So again, cirrus, these are the wispy feathery appearance. Stratus, it's sheet-like. And then cumulus are the globular masses. And then we have our vertical development clouds, such as the cumulonimbus thunderstorm clouds. So you can study off of that diagram as well as this table here when you review cloud classification. But let's go first, let's review the high clouds. So depending on the region, the latitudes, so the tropics, which are usually found between the latitudes of 0 degrees the equator to 30 degrees north or south, we see these clouds form above 6,000 meters, whereas in the mid latitudes this forms above 5,000 meters, and then the poles it's lower at 3,000 meters. So cirrus is Latin for curl, and cirrus clouds, since they're very high in the sky, they are composed of ice crystals where the air is cold and dry. And this is where we're going to see cirrus, cirrocumulus, and cirrostratus. So here we could see with the cirrus picture, these are thin, wispy, feathery clouds blown by high winds into mare's tails. And these are composed of ice crystals because they're tall, they're high clouds, and generally this means that the weather would be fair and pleasant, but increasing cover can indicate a front is on the way, and we'll touch upon fronts in a later lecture, but just know that fronts occur when air masses of two different densities and two different temperatures clash into one another, producing a front. And in each type of front scenario, we always have air rising, warm air rising, and as we know, due to adiabatic cooling, as the air rises, it will cool, reach its dew point temperature where it's saturated, the air is saturated, and it will condense and form water droplets. And their movement indicates prevailing winds at that elevation. So again, we're in the mid-latitude, so it will come from the westerly direction, from our major global wind belt, the westerlies. And then we have cirrocumulus. Again, cumulus are the little cotton balls. We see this pattern here, and this is also known as mackerel sky. So we have the small rounded white puffs that can occur individually or in long rows, and they could herald an advancing warm front when thickening. So again, cirrocumulus clouds appear as white patches composed of small cells or ripples. So the reason they're called mackerel sky is because it resembles fish scales. And then we have cirrostratus, and these are thin sheet-like high clouds that cover the entire sky and are so thin they veil the sun or moon, so we can see that halo effect. And ice crystals, they often bend the light, producing this beautiful phenomenon. And sometimes the halo is the only clue to the cloud's presence because they're so thin, and it gives the sky a hazy look, often forming ahead of advancing storms, and can be used to predict possible rain. So again, cirrostratus clouds are so thin and transparent that they are barely discernible. So those are the three cloud types found in the higher altitude. And now let's look at the middle clouds. And we have two clouds types found in the middle cloud section. So these are composed of water droplets and some ice crystals at low temperatures. And we're looking at altocumulus and altostratus. So again, we're looking at globular patches with the altocumulus, and then the altostratus, we're looking at layers of the clouds. So again, with altocumulus, there we could see the globular patches. So they're composed of mostly of water droplets and appear as gray, puffy, rounded masses or rolls. And they look similar to the cirrocumulus that we saw with that fish scale mackerel sky pattern, but these are larger and part of the cloud is darker than the other. And they called the nickname for these clouds are little castles in the air. And these types of clouds indicate rising air at cloud level, appearing often on humid mornings when thunderstorms can be expected in the afternoons. So again, these look different than the cirrocumulus that we just reviewed, because the cirrocumulus clouds were smaller and less dense. And next we're going to look at stratocumulus, which are the lower clouds, and those clouds will look different from this. They'll look thicker. Okay. And then our next one, it's altostratus. And here we can see in this image it has a gray, bluish gray sheet which often covers the entire sky, and the nickname that we see of these clouds would be watery sun. So we could see the sun looks like a water painting type of sun, muddy sun. There's no halo and no shadow cast on the ground. So this is different from the cirrostratus that we saw that had that halo around the sun. Here in this picture we see it's kind of muddy, like a watercolor painting. And these clouds are composed of ice crystals and water droplets and forms ahead of storms with widespread and continuous rain. And if this cloud starts to precipitate, base lowers, classifying it now as a nimbostratus. Now for our low clouds, again, strata means sheets or layers that cover the entire sky, almost always composed of water droplets, though in very cold weather could contain ice and snow. So the categories for those would be nimbostratus, stratocumulus, and stratus. So stratus, we can see here this photo of the stratus layer clouds. These are very common over coastal waters in spring, summer. This is also known as the marine stratus. So again, if you visit the beach, you'll often see this gloomy marine layer, also known as stratus. And so again, these are low uniform gray clouds that generally covers the entire sky. And unlike nimbostratus, precipitation rarely occurs, but cloud can produce light mist or drizzle. And for stratocumulus, we can see this is the globular patches are thicker compared to the altocumulus that we saw. And these are lumpy clouds appearing in rows or patches resembling cotton balls. And the color of these clouds vary from gray to white. And these are bigger than the altocumulus that I just mentioned that we saw in the previous slides. And precipitation is rare, but if the top is cool enough, some showers may occur as the clouds develop vertically. So a simple way that the book suggests to distinguish between these, the altocumulus and the stratocumulus, is to point your hand in the direction of an individual cloud mass, and if the cloud is about the size of your thumbnail, it is an altocumulus, and if it is the size of your fist, it is a stratocumulus cloud. So that is one way to decipher between the two cloud types. And then we have nimbostratus. So nimbostratus clouds derive their name from the Latin nimbus, which means rain cloud, and stratus, to cover with a layer. So these are dark gray, wet looking clouds, and they're darker than the altostratus, which we saw that had that muddy sun, the water painting type of sun photograph, and you cannot see the sun through it like we see here. So darker clouds, darker thick clouds associated with continuous light to moderate intensity rain, and visibility below this cloud is poor and often accompanied by fog. And nimbostratus drift rapidly with the wind, so ragged shreds of clouds occur beneath, called stratus fractus or scud. Now for the clouds with vertical development, again, cumulus means heap or pile in Latin, and the top of the clouds represent the limit of rising air. So we see three terms for the cumulus clouds, but when cumulus clouds are present early in the day, we can expect an increase in cloudiness in the afternoon as solar heating intensifies. Furthermore, because small cumulus clouds, cumulus form on sunny days and rarely produce appreciable precipitation, they are often called fair weather clouds. And these are the type of fun clouds that you can guess or be creative and see, oh, this cloud looks like a dog, for example. However, when the air is unstable, cumulus clouds can grow dramatically in height. As such, a cloud grows, its top enters the middle height range, and then in that range it is called a cumulus congestus. Finally, if the cloud continues to grow and rain begins to fall, it is called a cumulonimbus cloud.